So, ladies and gentlemen, we saw this morning a cacophony, for many of you perhaps, of new ideas. We encountered a running model which captured in an operational, in this case, runnable way, a certain hypothesis about the way the world is, or the way the world could be. And we saw that by running the model, we could see the logical implications of those assumptions as they impacted behavior over time. We saw that a model of that sort could be a fairly visual quantity, a fairly visual entity. The model was composed of components such as state charts, such as stocks and flows, things, these pieces, these building blocks that we're going to be spending so much time in coming days going over. And the model used those to characterize this kind of theory about the world, how things work or how things could work, so that we could use it as a thinking tool to think through the consequences of our assumptions with greater clarity. And these different pieces that we were using will differ from paradigm to paradigm. So if we're using system dynamics, we articulate our theory in terms of stocks and flows and a set of additional sort of convenience variables. If we are using discrete event modeling, we'll have a workflow characterized in terms of service blocks and queues and mechanisms for obtaining an agent, a resource for the entity and releasing that resource and having the entity, the agent, travel to a certain location. We may have batching and unbatching of items if you're dealing with quantities of physical goods that have to be divided up into pieces or combined together. Agent-based modeling has a different vocabulary yet. It has vocabulary that's somewhat more varied and has a distinction between model to model what pieces we use. So it includes state charts, it includes events, it includes these things called statistics in any logic. It includes variables. It includes action charts to make decisions. We saw that action chart involving someone's decision about what to eat, for example. And models in any logic are composed of these building blocks. And in coming days, we're going to be exploring these in much greater detail. So we might have something like this, and we're going to be displaying this palette, okay? The palette is something which gives us the ability to weave in these individual elements into the model. And in the system dynamics palette, there's a set of things that are different from what's in the palette associated with, for example, agent-based modeling. There's a lot of commonality. Parameters, for example, to encode assumptions. We may have variables in both. We may have functions or table functions to look things up in a tabular form. But there's somewhat different vocabularies. And that model we saw this morning actually mixed together a set of different vocabularies out of several pieces. And Scott will be interested to notice that in Linux there's this weird behavior with the palette showing up in the upper left. Here, if we go to person here, we'll notice that this person was composed of some pieces that were articulated in system dynamics to capture changes associated with the continuous variable weight through feedback-related processes. There's in fact two feedbacks here governing energy expenditure, one due to physical activity, one due to basal energy expenditure. But in that same agent, we had elements drawn instead from kind of the agent-based paradigm with decision-making characterized with an action chart and state charts. The fact that we use such visual elements is not an accident. Hope to talk about it later in the course, but I would be remiss if I didn't emphasize now, and emphasize to some degree on an ongoing basis, that modeling, ladies and gentlemen, is a human activity. Modeling takes place in a human theater. And as Jeff said, if we want to put in place fixes that stay fixed by building useful models that actually get used, it bears some reflection on the modeling process that we use. The modeling process is one that takes place not in a back closet of a nerd like me sitting in a windowless room poring over a keyboard and screen, but rather it takes place in a human theater occupied by stakeholders from many different backgrounds. And it's important to see a useful model that actually gets used. It's important that model incorporate features that are understandable by a wide variety of stakeholders. It's an irony, perhaps, of the situation that often when we go to build these models and we try to assemble evidence of relevance to these models, there's much evidence that is left under stones yet unturned. It's not until we actually run the model in front of someone sometimes, or show it to them in a very visual way, that often tacit knowledge gets elicited. You might think that people should be able to enumerate their knowledge in a very straightforward way about issues. But we as human beings often build up a lot of tacit knowledge, and it's not until we see something that reminds us of that, that we know this, that we seek to bring it forward. And it's my conviction, having worked on dozens and dozens, perhaps now hundreds of modeling efforts, that really much of the knowledge doesn't get fully tapped until we have a model that someone can look at. And it's not merely enough if that model be characterized in differential equations or be characterized as large sets of code in Java or C++ or some other language. Because it's hard to elicit knowledge from a stakeholder showing them a purely technical artifact like that. It's much more meaningful to show them a visual representation. And there are ways, if we were to build a model and that's to be characterized in C++, for example, there's ways to build up a visual representation as well. But it is nice to be able to also use packages where those are part and parcel of characterizing the model for the software to allow it to run, because it guarantees that our description will stay current with the current version of the model. So the fact that these are so visual, that lends itself to transparency for stakeholders, and as a result, confidence by stakeholders, perhaps buy-in from stakeholders at some point, in elicitation of new knowledge from stakeholders. It can also be a situation that's the difference between having a technical programmer build a model versus having, so to speak, a village to build a model. A group of people with very different knowledge, skill sets, knowledge of different pieces of the system who can contribute critique and suggest improvements. And indeed, much of our work has to do with working with stakeholders like this. Well, they'll look at a state chart and say, you're missing something, you need to add a transition from there to there. Or they'll suggest, wait, that's not a meaningful state, you really need to divide that into, instead of active TB, you need to divide into uninfectious and infectious active TB. Maybe there should be a category for cavitary TB. By looking at the model, it's transparent enough that they can bring suggestions. Now, do they have perfect understanding of what's going on in every little detail? No. There are some elements that are not obvious to them, but a lot of the assumptions are made clear enough that they can critique them. And because modeling is a human effort, and because models are learning tools, that's very, very important to be able to elicit that knowledge over time. So the package we're using here, and I think it's used as the tool for this boot camp for two primary reasons. That's one of them, because it is a visual tool, and because the creators have committed themselves to using visual representations that are transparent, can be transparent to a wide group of people. And secondly, because it allows us to weave together these multiple paradigms. So here, there can be lions alongside lambs. We have a characterization of weight using a system dynamics paradigm, and beside it, we have a characterization of a person's food-seeking behavior characterized with state equations, and yet down here, a characterization of decision-making with what are called action charts within any logic. All of these are pieces that you can add in. All of them have technical details associated with them that we will touch on this week. But it bears noting that our use of them has much to do with wanting to build useful models that get used, to put in place fixes that stay fixed in the alliterative or consonant expressions of Dr. Jeff McDonald. This is a little bit of a reflection. We're going to be talking about the first part of this process in coming minutes, the process of, ladies and gentlemen, model conceptualization. And if you go to the slides provided to you, there's a document, a PDF, which introduces to the modeling process that it might be good to look at here. And once again, I'm having a devil of a time. I'm not sure if only a subset of these PDFs got there or what, but it's almost like a few. Oh, here it is. Overview of modeling process 1. Okay, this document should be on your slides area if your thumb drives or of the website. It talks about some features of the modeling process. I don't have time to go through this, but I want to highlight a few facts about it. Number one, it's structured. There's order there. There's an orderliness to it. Number two, it's iterative, properly undertaken. One iterates towards a model. One doesn't sort of anticipate a big, great model 2 years from now. Just put your nose to the grindstone, hunker down, and build it. And 2 years from now, you're done and can conduct rich experiments. It is overwhelmingly important to build up a model in a step-by-step fashion where you're running it along the way, you're learning from the model, you're spotting errors that come in, etc. It's important for stakeholder confidence, it's important for your understanding of where dynamics come from, it's important for your prioritization of what comes next, it's important for spotting issues. And it takes place in a set of stages that are iterative, and there's both forward movement and backwards movement. We're going to be talking about this very thorny first issue of problem conceptualization first. We're going to continue on to a discussion of qualitative problem mapping. So characterizing our understanding of the situation in a more qualitative or semi-qualitative fashion, semi-quantitative fashion, before proceeding on to the topic that will accompany us for much of the week, which is really model formulation, building a working model, a living, breathing model that can be run. Qualitative problem mapping and problem conceptualization have to do with the boundary of the model, what we're capturing in there. Model formulation gets us to the point of a runnable model. Model calibration is checking to what degree that model accords with external data and in adjusting our assumptions within the model so that it best accords with it. And we go through a process of model testing often alongside it. Here shown as it happens after, but it's really accompanies it. And even model formulation. And then we may end up using a model in policy evaluation or knowledge translation of the model, findings from the model about which we have confidence because we've gone through these earlier stages. I put in here features of each stage, common tasks that we undertake at each stage. We're going to focus for the balance of the afternoon on this area. But this brings up another area in which I've been remiss, where I stand to be corrected. I should have emphasized this morning, I did emphasize this morning that this boot camp, the priority of it is to answer your questions, to deal with your needs, to deliver value to you. The different parties in this room, for the participants, are at very different stages of their journey. Jeff talks about the modeling journey as one that every person must undertake on their own. And some people here have been in modeling along that journey for a longer time than others. I'm going to talk about this first stage because it's a stage in which many people just starting on it, and even those who are returning for their second or third model, often really have challenges. It's also a stage which I find that there's little support for, and shockingly that is the most vulnerable stage, but the one that's least supported by existing documentation and books, etc. So I'm going to cover it in some depth. But some people in here might be more at this stage. You're in the model formulation stage. You know what you want, and you're looking to get it far down the pike in terms of those elements. Or maybe you're at this stage, partial model formulation, but you probably got to refine the model, testing it with some data, and you want to take that and drive it down the road. That's great. If that's the situation you're in, grab a TA. We do have that projects document here. Grab a TA. We've articulated students that I think will be particularly good to support you. Go grab a student at any time. Feel free to go off. They can show you where rooms are for breakout discussions, and you can be out there advancing your model. I'm fully supportive of that. If that's what you think will help deliver value, power to you. I think that's awesome, and I'd rather you do that than have to sit through lectures that don't speak to your needs. But I do want to spend the balance of the afternoon here until we to the very later stages to really try to grapple with this issue of model conceptualization and formulation. How do we set the boundary of our model? Given that models are abstractions, they hide a lot of detail. We leave things out, like with maps. How do we be artful in what we leave out? How do we select what we leave out, what we include? What we include at first, what we include on an ongoing basis? What shapes that? We'll show you some tools for mapping out models, not just in one paradigm. Closed loop diagrams are formidable, and I'll introduce them, but also tools for agent-based and hybrid modeling, and tools for discrete event modeling to sort of map out our understanding of the situation. We'll be talking about some heuristics to sort of help you think through the situation of what you might capture in this model and some ways of heading off common student mistakes. But if any of you would like to take a TA, you feel that doesn't speak to your needs and you'd like to grab someone, fantastic. I'm delighted to see that done. So we're going to be starting today in this stage. Starting late today, we're actually going to go to the first stage of model formulation. We're going to have a lot of interactive fun with any logic, with some model formulation. Okay, we're going to be running little models that have some interesting patterns of heterogeneity, etc. And we might even get to some dynamics in terms of state charts if we're lucky. And later stages we're going to be going through in the next few days. But my first focus is this one. Those were reflections and segues from this morning. Are there any questions that people may have that came up this morning before I dive into these first two areas of focus? Okay, so seeing no questions asked, I think that I will proceed now to discuss and grapple with the thorny area of model conceptualization.